So check here. This is important because we're going to do the examples here. And walks 2 kilometers north and then 7 kilometers to the northeast. What are they telling you? Show what? Draw displacement. So first of all, walk 2 to the north, that's mean up. So 2, here's 1, 2. Then 7 to the northeast. So which one is going to be? You have 4 options. Which one are you going to choose? Like you're going to walk north, then you're going to walk northeast. So this is the option. So you're just going to choose this one. Don't think it's going to hard on WebAssign. Draw a vector. Here is the difference. The first one is telling you to draw displacement. Okay, so we're just going to draw north, then northeast. The second one, they're telling you to draw a vector. Represent this one. So here is the first one. Where is the vector? You see the distance. Here is the distance. We have to draw the vector. So it's going to be from this point to the end point. Okay. How much is the point here? 7 and 5. The draw vector that represents the net displacement from the starting point. So which one are you going to choose? This one, or this one? Or this one? Which one do you think? 7, the first one, 7 and 5. So you're just going to choose this one. Yes or no? Is that hard, these examples? Yes or no?
Not really, no.
Let's keep going, because I need to go to the important thing, how to use the binary operation. Okay, I'm going to show you. And we're going to go back on papers. Now, refer to the vectors below. C and D. Compute D minus C. Is that hard? You're just going to say -9 minus, D, 4, but be careful. Be careful. Sometimes you're going to do mistakes with the sign. Okay, so 4 minus -9. Okay, so it's going to be +9. That means it's going to be 13. You're going to write down 13 here. -9 minus 4 is going to be -13. Okay. How are we going to, here is 13. Now here is our vector and -13. How are you going to graph it? Let's say I'm going to graph the vector here. Don't confuse yourself about all these graphs. 13, here is 13. Okay, 10, it goes by 1, 2, 3, by ones. Here's 13. Okay, what about -13? It goes down, right? So you're gonna graph, so here is the point. You're gonna graph a line from 0, 0 to the point. So which option is going to be the right one? This is 13, 10, 11, 12, 13. And this is 10, 11, 12, 13. So what about this one? Oh, because this is C and -D. Which option you're going to choose? This one or this one? Why are you going to choose C? Because check the C. the vector C. How much the vector C? -9, 4. So graph it. Where is -9, 4? Is this one or this one? Here is the C on this graph. This is not -9 and 4. So don't choose this one. Let's check the D. 4, -9. Four, and here is -9. You see what happened to the D? So we're going to choose this one. You just analyze. Okay. Check the vector, one of these vector D. So you see the D is exactly the right one. And the distance, the D minus C, which is the right one. So we're going to choose this one. Now, what about this one? Is this one hard? And again, be careful from the numbers. When you multiply, when you add, just be careful because you're going to do an easy mistakes here. Okay. That's what I'm telling you here. They're going to tell you which operation you're going to use, which one of these properties you're going to use. Like, for example, here's this one. Check here. What happened here? Distribute the 4. Okay. What the next step? So here you're going to choose, because here's the operation. That's mean distribute. Which one is distributing? The 4. That's mean you're going to say E. Okay. But he used another operation. Which one he used? After distributing, distribute the 4, distribute the 5. Then what he did? B, A. A, B. What happened here? A, B, B, A. B. So we choose that. We have to choose more than one properties. So we said E is right, distributing the scalar. What other properties we have to use to get this one?
Is it property A maybe?
Immutable property, that's mean you're gonna switch. You're gonna change these two.
Yeah,
So,
like
A,
A
and
and oh, there's no option for A with
it says
E.
A and C only with the E.
Oh, okay. So
Here's the thing. When you distribute the number here, when you distribute the number here, let me show if I can write down. When you distribute the 5 on this, now this is the which property? Property E. Distributive property. Now it's going to be 5 parentheses 4B minus, I'm not gonna work on this one. Now look to this part. We have 1 scalar, 2 scalar, variable. Is that this property? Because scalar and variable, which is the vector. That means it's going to be multiplying these 2 scalars together. Okay, that means which property? So it's going to be, look, 5 times 4, and here's the B. That's mean E and G. So you have to choose E and G. There we go. Then you're right. Now you're going to use A because you're gonna commutative property by these two vectors. So you see 4a, and you're gonna flip these two together, and you're gonna use associative property, which is going to be A and B. Okay. You just have to focus on the properties. That's two. Now I need to here is. What about this one? The next example. Just to find the x, just solve it exactly the same thing. They're gonna ask you any property, you're gonna distribute, and that's it. And put down the x on one side and A and B on the other side. Is that hard to find? Yes or no? Be careful here. It says what? Binary vectors. What's the meaning of binary vectors? Binary. What's the meaning of binary? When you hear the word binary.
Two
what?
vectors or components.
That's good. Okay, that's good. But we're talking about binary operation. Now it says binary vectors. That means he's talking about binary operation. What's the meaning of binary operation? You said two numbers, which is 0 and 1. Okay, so when you see now, they're not going to tell you binary operation. They're going to tell you Z. Okay, so if you see Z2, let's go back to the. I'm going to stop sharing. So we're going to work because this is the important thing now for the whole thing. That's why I'm telling you. Next time you're gonna watch this, check the slides. So we're gonna work on the examples. So here's the thing. You said binary. So when you see Z2, Z2, this is the binary. How many numbers? 2 numbers. Z3. How many numbers? 1, 2. How many numbers? So Z4, how many numbers is going to be? 1, 2, 3, and 4. And keep going. Z7, Z6, okay? So when you see Z sub number, start from the 0 and keep going, because we're going to use this one. Now, how is the real number with Z2? The real number I'm talking about. Here is the real number. 0, 1. This is R, okay? 2, 3, 4, 5, 6, and keep going. Now, the real numbers with Z2, with the binary operation, is going to be 0, 1. Then 0, 1, 0, 1, 0, 1, and keep going. Okay? So now, the 3, it's a real number. But on Z2, how much is going to be? It's going to be what? Which number? 3, it's a real number, okay? 3, real number. But if I ask you 3 in Z2, how much is going to be? It's going to be 1. How are you going to write down 3 in Z2? It's going to be 1. How are you going to write down 5 as a real number in Z2? It's going to be what? 1. I'm just showing you. I'm going to give you an easier way, okay? Now, in Z3, how many numbers? 3 numbers, okay? How are we going to write down? Z3 is going to be 0, 1, 2. 0, 1, 2. 0, 1, 2, and keep going. Now 5 in Z3, how much? 2. 2 in Z3, how much? 2, the same thing. 0 in Z3, how much? 0. Now let's see Z4. Z4, that's mean 4 numbers. 0, 1, 2, 3. Go back again. 0, 1, 2, 3. And keep going. Let's say this is 7. 4 in Z4, how much? How much? 4 in Z4, how much? 0. Let's go back to the 0. I'm going to show you how it's going to be easier. Just showing you. Let's go back to the example we have. I'm just going to write down the vectors. U equal 1, 1, 1. And V equal 1, 1, 1. 1, 1, and 0. Let's use the binary operation. This is the example on the WebAssign. U plus V. So they're telling you find binary vectors, okay? That's mean Z2. So here is Z2 equal. Tell me the numbers. 1, only these 2 numbers, okay? Because it's a binary vectors. Now we're gonna add these 2 vectors. 1 plus 1, it's 2. I'm talking about the real number. 1 plus 1, 2. Let's count. 1, 2. That's mean how much the result? How much the result? I'm talking about now Z2. The result is going to be 1. Okay, so it's going to be 1. 1 plus 1, 2 in the real number. What about 2 in Z2? You're going to say 1, 2. How much the result? It's going to be 1 because we're talking about binary operations, okay? Binary vectors. 1 plus 0, 1. 1. So how much the result? So that's the result. How are we going to count? Again, let's say, let's do another example. So you're going to figure out the whole thing. Here. Find 3, 2 plus 3 plus 3 in C4. Z4 is, tell me the numbers, 1, 0, 1, 2, 3. That means we have only how many numbers? 4 numbers. 0, 1, 2, 3. Do not look to this one. Now, if you add and multiply these numbers here on the side, how much the result? 2 plus 3, 5. 5 plus 3, 8. 8 times 3, 24. Yeah, the 24 as a real number, okay? Good thing, 24 as a real number. So I'm gonna write down, this is going to be 24 in R. The questions they ask you, find 24 in what? In Z4, okay? So check what I'm going to do. 0, 1, 2, 3. I'm gonna go back. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So how much 24 in Z4? So it's going to be equal, that's meaning 3, 2 plus 3 plus 3 is going to be equal 0 in Z4. You got it? Because you have to go back and count again and keep count until you reach the 24. That's mean 24, which is the real number, but is going to be equal to 0 in Z4, okay? We're gonna do another example. Any questions so far? Oh, these are questions. Let's find another one. From the Z4. Okay. This is really important. Here's another one. Find two plus 1 plus 3 in Z3. Z3, how many numbers? 3 numbers. So write down Z3 is going to be equal 0, 1, 2. Be careful, it's in just the 3 numbers. Now, how much the result if you count this one as a number? 2 plus 1, 3. 3 plus 3, 6. 6 times 2, 12. Okay? Now we're gonna count here. 12 in Z3 is going to be what? Tell me. 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how much the result? 0. That's mean this one, 2 plus 1 plus 3 is going to be equal 0 in Z3. That's it for this example. Any questions so far? We're just gonna count the numbers. Keep going back until you reach how much the number 12. You're gonna choose that number when you stopped here. Okay. Now we're gonna do the same examples, but it's going to be equations. For example, this one. X plus 4 equal 3 in Z3. They're gonna ask you to solve. How are we gonna solve? Because we need to find the value of X, okay? So check, Z3, how many numbers do we have? 3 numbers, which is 0, 1, and 2. Now I'm gonna start plugging the first number because I need to find the value of X, okay? So what I'm going to do, I'm gonna say X equal if X equals 0, plug in 0 here. How much the result here? 4 equal 3. Is that right or no? Is 4 equal 3 in Z3? Let's check that. 0. No, it's in Z7. Sorry. So Z7 is going to be 0, 1, 2, 3, 4, 5, 6. Now, plug in the 0. Is 4 equal to 3? Let's count. 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4. So 4 equal 4. Like this is the real number. This is the real number. Count 4. 0, 1, 2, 3, 4. So 4 in Z7, how much equal? Equal 4, not the 3. So this is wrong. Now if X equal 1, Plug in 1 here. 1 plus 4 is 5 equal 3 in Z7. Let's check that. 0, 1, 2, 3, 4, 5. So 5 equal 5 in Z7. That means this is wrong. Keep going. If x equal 2, 2 plus 4 is going to be 6. Is 6 equal 3? 6 equal what? Equal 6. So this is wrong. If x equal 3, by the way, how I'm going to choose the x from here? The x from here, you're going to choose it from the same z. You're going to stop until 6. Okay, so x0, I'm going to choose x0, x1, x2, until x6. Then I'm going to stop. I have to find one of these x's is going to work. Okay, so x3, that means I'm going to plug in 3 here. 3 plus 4 is going to be 7. Is 7 equal 3? 6, 7. 7 equals 0. Because we're going to go back. Okay, so that means this is wrong. If x equal 4, plug in 4 here, so it's going to be 8. Is 8 equal 3? 6, 7, 8. It's equal 1. So this is wrong. If x equal 5, plug in 5 here, so 9 equal 3. Is 9 equal 3? Let's check. This is 6, 7, 8, 9. 9 equal 2. We're going to go to the last number. If x equals 6, plug in the 6 here is going to be what? 10. Is 10 equal 3? This is 6, 7, 8, 9, 10. You see 10 when it end? On the 3. That's mean how much the x, which is the solution? How much the x? 6. So this one is going to be the solution. I know it's a longer process. You just have to focus. I have another example. You want to do the same, exactly the same example, like this one? Just like 1 minute. Yes. Here's another example. You want to write down these. It's easier one. So you can learn this process. So if you have also solve x and you have 4x equal 1 in Z5. Z5, how many numbers do we have? 5 numbers. Here's Z5 equal 0, 1, 2, 3, 4. Here's the numbers. Now we're going to start with the first number with the 0. So I'm going to start with the 0. Plug in the 0. If x equals 0, 0 equal 1, 0 equals 0. That means this is wrong. If x equal 1, plug in the 1 here. 4 times 1 is going to be 4. Is 4 equal 1? 1, 2, 3, 4. So 1, 2, 3, 4. No, 4 equal 3. 0, 1, 2, 3, 4. 4 equal 4 in Z4. Okay? If x equal 2, 4 times 2 is going to be 8. Is 8 equal 1? Let's check that. 0, 1, 2, 3, 4, 5, 6, 7, 8. So 8 equal 3, not 1. So this is wrong. If x equal 3, 4 times 3 is going to be 12. Is it 12 equal 1? Let's check that. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So equal what? Equal 2. That means this is also wrong. If x equal 4, 4 times 4, 16. Is 16 equal 1? 1 is, sorry, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You got it? So that's mean 16 equal 1 in Z5. So how much the result? X equal 4. That's mean x equal 4, which is the solution.